Hello students, welcome to physics class. Today we discuss the combination of errors in a measurement. An experiment involves the measurement of various physical quantity and the final result is obtained by the calculation by using different physical phenomena. The error in the final result depends on the error in the individual measurement and the mathematical operation involved in the formula. Today we discuss the different rules to calculate the maximum possible error in a final result in an experiment. Let us see what are the rules to find the maximum possible error in a final result. Suppose we are measuring the two physical quantity A and B and we are finding the final result by adding A and B. That is error in the sum of two quantities. What is the maximum possible error in the sum of two quantities? For that, we measure two physical quantity A and B. There are error in A and B. Let us say delta A and delta B are the error in A and B. They are the absolute error. Delta A and delta B are the absolute error in A and B. So we can write the A is equal to A plus or minus delta A and B is equal to B plus or minus delta B. This is the way to represent the final measurement. A is equal to A plus or minus delta A, B equal to B plus or minus delta B. And we finding the result set. Set is the sum of A and B. So we can write the error in the Z is delta Z. Let us say delta Z is the error in the final result, that is in Z. So we can calculate what is delta Z. So Z plus or minus delta Z. This is the final result. Z plus or minus delta Z is equal to A plus B. We know that A equal to A plus B plus or minus delta A plus delta B. We are just adding A and B and adding the absolute error in A and B, that is delta A plus delta B. And we can rewrite this A plus B as set. You know that A plus B is equal to set. So instead of A plus B, we are writing set plus or minus delta A plus delta B. So by comparing these two equations, we can write as the maximum possible error in Z, that is delta Z is equal to delta A plus delta B. Delta A plus delta B. That is the maximum possible error in the sum of two physical quantity is the sum of absolute error in that measured quantity. The maximum possible error in the sum of two quantity is the sum of absolute error in the individual physical quantity. That is delta Z is equal to delta A plus delta B. For example, if you are measuring the two length, L is equal to, L1 is equal to 2 plus or minus 0.1 and L2 is equal to 3 plus or minus 0.2 centimeter. And what is L1 plus L2? L1 plus L2 is equal to first 3 plus 2, that is equal to 5 plus or minus 0.1 plus 0.2, that is equal to 0.3 centimeter. That is the maximum possible error in the result is equal to 0.3. That is we added delta L1 plus delta L2, that is equal to 0.1 plus 0.2, that is equal to 0.3. Now error in the difference of two quantity. Error in the difference of two quantity. That is we measuring two quantity A and B and the result is A minus B. Result is A minus B. So we can write the set plus or minus delta Z. This is the result with the error. Z plus or minus delta Z is equal to, first find A minus B, that's equal to A minus B plus or minus delta A plus delta B itself. It's not delta A minus delta B because the error is always getting added. There are error in the individual measured value. They will not decrease when you are calculating some result by using that value. Error is always getting increased if you are doing any mathematical operation. If it is addition or subtraction, it is always delta A plus delta B. Now write delta A minus delta B. Remember, it is delta A plus delta B itself. So set plus or minus delta Z is equal to A minus B. You can write as set plus or minus delta A plus delta B. By comparing this equation, we have delta Z is equal to delta Z, that is the maximum possible error in Z, is equal to delta A plus delta B. That is the maximum possible error in the difference of two physical quantity is the sum of the absolute error. The sum of absolute error in the individual reading, delta A plus delta B. For example, if you have two measurements, that is L2 is equal to 2 plus or minus 0.2 centimeter and L1 is equal to 1 plus or minus 0.1 centimeter. And what is L2 minus L1? What is L2 minus L1? So first find 2 minus 1, that is equal to 1, plus or minus 0.2 plus 0.1, that is equal to 0.3 centimeter. That is the maximum possible error in the difference. L2 minus L1 is 0.3 centimeter. That's the rule. Now, the third rule in the multiplication, error in the product of two quantities. We are measuring two physical quantity A and B, and we are finding the product of A and B, that is A into B. So the measured quantities are A equal to A plus or minus delta A and B is equal to B plus or minus delta B, and Z is equal to A into B. Let's see, the delta Z is the maximum error in Z. So we can write Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. Just remove the bracket by multiplication. A into B. So we are writing A into B. A into delta B. That is A into delta B. Now second term, delta A into B. Delta A into B. And the final term, delta A into delta B. Delta A into delta B. The left side is Z plus or minus delta Z itself. Now we are dividing on this equation. We are dividing the LHS by Z and RHS by AB. We are dividing the left hand side of this equation by Z and the right hand side by AB. So we are getting Z divided by Z, that's equal to 1. Delta Z divided by Z. So we can write as delta Z by Z itself is equal to AB divided by AB, that's 1, plus or minus A into delta B divided by AB. So A and A getting cancelled. So we are getting delta B by delta B by B plus delta A into B divided by AB. So B and B getting cancelled. So we are getting delta A by A. And the last term, delta A by A into delta B by B. Okay. We know that delta A by A and delta B by B are the relative error in A and B. Delta A by A and delta B by B is the relative error in A and B. Already know that relative error is too small. So if delta A and delta A by A and delta B by B is too small, their product delta A by A into delta B by B is further small and negligible. So we are just neglecting this term delta A by A into delta B by B because it is too small and negligible. And the final result can be write as 1 and 1 getting cancelled. the delta z by z is equal to delta a by a plus delta b by b. The result is the relative error in z, that is delta z by z is the relative error in z, is equal to the relative error in a plus relative error in b. That is, if you are multiplying a and b, the maximum possible error in the result, the relative error in the result is the sum of relative error in the measured quantity, delta a by a plus delta b by b. That's the final result. Now let us see what is the error in the division or quotient. So we have two measured quantity a and b. We are writing a is equal to a plus or minus delta a, and b is equal to b plus or minus delta b, and z is equal to a by b. That is, the result z is equal to the ratio between a and b, a by b. So delta z is the maximum possible error in z. So we can write as z plus or minus delta z is equal to a, substitute for a plus or minus delta a, b plus or minus delta b. So the z plus or minus delta z is equal to, we are making a rearrangement. From here we are taking a outside of this bracket. Once you are taking a outside, here 1 plus or minus delta a by a, delta a by a. From here we are taking b outside of the bracket, so we can write as b into 1 plus or minus delta b by b. Check the result. We are multiplying by a, it becomes a plus or minus a delta a by a and a getting cancelled. We are getting the same. So we can write a plus or minus delta as a into 1 plus or minus delta a by a, and b plus or minus delta b can write as b into 1 plus or minus delta b by b. And rearrange the right side as a by b, keeping together a by b, and 1 plus or minus delta a by a here itself, and we are taking this one here. So 1 plus or minus delta b by b whole raised to minus 1 is the, because 1 by x is equal to x raised to minus 1 in that form. Now the left side, z plus or minus delta z is equal to z a by b, you are writing as z because a by b is equal to z. Then 1 plus or minus delta a by a into 1 plus or minus delta b by b whole raised to minus 1. And we are using this binomial theorem to expand 1 plus or minus delta b by b whole raised to minus 1. By binomial theorem, we know that 1 plus x whole raised to n is equal to 1 plus nx if x is very less than 1. You know that delta b by b is too small, so we can use the binomial theorem to expand 1 plus or minus delta b by b whole raised to minus 1. Once we are expanding that one, so when you are comparing this two, instead of x we have delta b by b, and it is too small actually. So we write as 1 plus, instead of x we are writing delta b by b. Instead of n we have 1 here, minus 1 here, so we are multiplying by minus 1, so you can write as plus or minus into minus 1, so it become minus or plus, minus or plus. The meaning is same only, no problem if you are writing plus or minus or plus. So 1 plus or minus delta b by b whole raised to minus 1, by using binomial theorem, 1 plus x whole raised to n is equal to 1 plus nx. We are using that binomial expansion though, and we are getting this 1 plus or minus delta b by b. Now dividing both sides of this equation by z, you are getting 1 plus or minus delta z by z is equal to 1 plus or minus delta a by a into 1 minus or plus delta b by b. Okay. Then 1 plus or minus delta z by z is equal to, multiplying this, 1 into 1, 1 into delta b by b, delta a by a plus delta A by A into delta B by B. But you know this quantity is too small and negligible. Delta A by A into delta B by B is too small because delta A by A and delta B by B are too small and negligible. So we can write the final result. If this term is negligible, you can write the final result as delta Z by Z is equal to delta A by A plus delta B by B. That is, the relative error in the final result is equal to the relative error in A plus relative error in B. The relative error in the Z is equal to relative error in A plus relative error in B. Now let us see what is the error in the power of a physical quantity. Error in the power of a quantity. That we measure a physical quantity A and writing A equal to A plus or minus delta A. And we are finding the Z as the power, nth power of A. Z is equal to A raised to n. You have to calculate what is the error in Z. So the maximum error in Z if delta Z, we are writing Z plus or minus delta Z is equal to A plus or minus delta A whole raised to n. And on the right side, we are taking n outside, that's A outside of this bracket, A outside of this bracket. Once it come outside, it become A raised to n. Because inside the bracket we have a power n, outside A raised to n. So once A take outside, it become 1 and delta A by A. So A raised to n into 1 plus or minus delta A by A whole raised to n. And A raised to n we can write as Z, and we are writing A raised to n is equal to Z. 1 plus or minus, we are using our binomial theorem, that is 1 plus x whole raised to n. We are using 1 plus x whole raised to n is equal to 1 plus n into x if x is very much less than 1. So as delta A by A is too small, we can use this binomial theorem, n into delta A by A. Divide on both sides by z, we are getting 1 plus or minus delta Z by Z is equal to Z and Z getting cancelled. 1 plus or minus n into delta A by A. 1 plus or minus n into delta A by A. So the maximum possible error is equal to delta Z by Z is equal to n into delta A by A. That's the maximum possible error in A. So the error in A is increases by n times once we are calculating the A raised to n. So in any measurement, if you are using the power of that measured quantity, you should take very much care while measuring that physical quantity, because that power times the error will be increased in our result. Then the general rule, if a physical relation contain all this multiplication, division and power, we have a general rule to calculate what's the maximum error in the result. That is, Z is equal to A raised to P, B raised to Q and C raised to R. So what is the error in Z? We are writing the fractional error, or the relative error in Z is equal to P times of the relative error in A plus Q times of relative error in B plus, not minus, plus R times of relative error in C. This is our physical quantity. Z is equal to A raised to P, B raised to Q divided by C raised to R. What is the maximum possible error in Z? So the relative error in Z is equal to P times of the relative error in A plus Q times of the relative error in B plus R times the relative error in C. That's a general rule to find the relative error, or the maximum permissible error in a result if there are error in the measured quantity. That's all today. Thank you.